Hello everyone. Today in this video we'll be discussing the second module of big data. So in second module there are three topics. So from these three topics very super important questions are there which are 8 to 10 marks. That's what I'll be discussing in this video. Okay. Also, what are the key points you need to write, what are diagrams are important, those all things you will be learning in this module. Okay. The key concept in this module is Hadoop. Okay, we'll be learning the things regarding the Hadoop, the basics of it, and the tools used in Hadoop. Okay, so I've divided this video into, divided this module into three parts. The first video I'll be covering this one, and then in the next part and in the third part I'll be covering this one. Okay, so I'll be explaining this one. So only I have divided into parts, and I'll be telling you how to remember each question and what are the key points in it. So before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. Your support helps me make more videos like this. In this module there are totally 6 topics. Okay, I mean in this topic introduction to Hadoop there are total 6 subtopics. Okay, so I'll be covering each topic one by one. Okay, so this is the topic first, which is big data programming model. What do you understand by big data programming model? To handle the big data there is a model, which is the programming model, that key concepts you are learning. Okay, so to store any data you need a central or distributed model. There are two types. If you are asked with this question, is a super important question. Differentiate between central and distributed model. The first thing what you have to write is a few keywords about the central model, then a few keywords about the distributed model. So what are the things you need to write in the central model? As you know, the basic difference between central model and distributed is a central model will have the server at one place and all the data will be stored there itself, whereas in distributed model you will have different databases in different places and all will be interconnected with each other. They will be sharing the data. So there are advantages and disadvantages of each of these. Okay, so first point in central model is what you will be writing is a programming model centralized computing of data. Okay, in which data is transferred from multiple distributed data sources to a central server. So there will be a central server and all the data from the different sources will be transferred to one central server. Okay, and the tasks include, the second point you will be writing, analyzing, reporting, visualizing, business intelligence task, compare and centrally. Okay, so all these things will be performed centrally. Then there are some inputs and the outputs. Data to the inputs to the central server, and from the central server the outputs are sent. So these are the basic 3 points which you are supposed to write. Coming to distributed model, the another programming model, and that's the first point, which is distributed computing that uses databases at multiple computing nodes. This is the key point. Multiple computing nodes are there. There the databases are distributed and the data sharing between the nodes during the computation happens. That's the first point. Second point, you will be writing about the model requires the cooperation or the sharing between the databases. Third point is this: it is transparent that each user within the system may access all the data which is present in all the databases. Okay, so this is what you need to write for the first question. Also the second requirement is there, which is location independent. Wherever the data is present, that should be accessed. Okay, moving on, we have the next important question, which is explain the concept of distributed pieces of code. What do you understand by the term distributed pieces of code? The pieces of code are distributed at different places. That's what it is called, distributed pieces of code, isn't it? So that's what we'll be writing. The first point is transparency between the data nodes at computing nodes do not fulfill for big data. The transparency is not fulfilled for big data when it is distributed. That happens because of the following reasons. Okay, why it happens is because distributed data does not use the concept of joins. Even if it doesn't make any sense, just keep this in your mind. You'll be getting to know these actual meanings in the upcoming topics. It does not use the concept of joins, and it needs to be data needs to be tolerant. If there is a faulty data, it should not cause any big problem. Because of these two reasons, transparency is not there. If these two were accepted, then the transparency would have been removed, then the distributed process of code would not have been required. Okay, so mainly you need three things. The next last point which you'll be writing is it's the cap theorem. Cap means consistency and availability, and P means partitions. These three things, when it's fulfilled, that means it's a good system for storing and processing data. Okay, at least two must be present. Okay, moving on, we have the third super important question, which is explain the big data models. How many models are there? Two models are there. Okay, big data, there are two models. The first one is big data store model. In store model, the first thing you'll be writing is it consists of files in the data models that are stored in the racks in data clusters of Hadoop system. Racks are there, and in the Hadoop system it is stored. That's the first point. Second point you'll be writing is it uses data store model, which is in which the storage of the clusters, racks and data nodes and the data blocks. Actual architecture is there will be cluster, inside that there will be racks. In each rack there will be some nodes. In each node there will be some data block, and data block is 64 MB. Okay, so in that way the data files are getting stored. So you'll be learning the architecture in the upcoming topics. Okay, so for now you'll be remembering, if they ask about the big data store model, just define it, what it consists of, and how it is architectured. Coming to the next one, which is big data programming model. In programming model, the application in which the program application jobs and tasks is scheduled on the same servers that store the data for processing. In this, there is no separate storage for different and processing for different. It is in the same part. Okay, that is what programming model is. The data processing and the data storage is in the same part. Okay, that's what you have to write in the big data models question. Okay, that is about the first topic. Moving on to the second topic, we have Hadoop and its ecosystem. Hadoop is a software for storing and processing large data. Very large data is there. It's used for storing and processing. It has some tools which it uses, which consist of which comprises the ecosystem. We will be learning about that now. The first super important question: what is Hadoop? What is Hadoop? It is a computing environment in which input data stores, processing, and stores the results. What it does is it processes large data and stores the large data. Okay, that is what is Hadoop. How it works? The next question: how it works? It works based on the clusters. It consists of clusters which distribute at the cloud and the set of servers. It uses those clusters to store the data, and it uses some Hadoop tools to perform the operations on the data. And a bit more information regarding the storage is given here. Each cluster consists of a string of data files constituting of data blocks. In each cluster there are data files stored in the form of data blocks. So this is the about the storage, and finally they have asked about what is its uses also. So Hadoop platform is a low cost. It is a data platform which is open source and uses cloud services. Terabytes of data processing can be done in just few minutes. That's the use of Hadoop. Okay, to process large data. That's all, one line. Okay, by that you have to expand. Moving on to the next super important question, which is what is MapReduce? Super important question. Okay, what are its three properties? So what is MapReduce? By the name itself you can understand. Map means there are key and the values it is getting paired or the mapped. Reduce means reducing its complexity and removing the irrelevant data. That is MapReduce. So Hadoop has a large number of data, right? We need to use MapReduce so that only relevant things will be processed, not all the data will be processed. Okay, and it has three properties with that as well. Let's see what it is. Hadoop, and this is the first one you need to write. Hadoop enables the distributed processing of large data sets over 10 million bytes. How many bytes will be there? Above how many bytes will be there? 10 million. More than 10 million bytes will be there, and it's distributed across clusters of computer. So all the data is distributed. Okay, in Hadoop you must remember all the data is not present in one place, but it is distributed in many places, and we use a programming model called MapReduce to perform it. What is MapReduce? In more detail learn in the upcoming topics. The system characteristics, three are there. How many are there? Three are there. The scalable, self-manageable, and self-healing. Okay, in the distributed file system there are three characteristics is scalable, self-manageable, and self-healing. Scalable, what do you mean? It means it can be scaled up. Self-manageable, what do you mean? Creation of storage and processing of resources. Okay, and self-healing means what? In case of faults, the system must take care of itself. Okay, these are the three characteristics of MapReduce. Moving on, we have the third super important question. Explain Hadoop core components with a neat diagram. Observe carefully. They can ask you about the ecosystem as well. They can ask about the essential tools. They can ask you about the architecture. They can ask you about the execution model. They can ask you about the core components. Many different questions are there, so pay attention too much. Fine. Then only you will get to know what answer you have tried for what. Otherwise, you will lose marks like a stupid person. Okay. So what do you write in core components? How many core components are there? 4 core components. Okay. This is super important, because separate questions have been asked regarding each of these core components. Okay, and a separate module is only there for each of these, means explaining this in depth. Okay, so this is the basic foundation you need to have. In Hadoop, how many four components are there? Core components, 4 core components are there. Which are those 4? First you have to draw a diagram. First you will be writing common libraries and utilities. This is the first component of core component of Hadoop. Common libraries and utilities means it will be having all the predefined things which you can use for execution. Okay, second is HDFS, distributed storage. We need to store something, right? For that we'll be using HDFS. A part of the module module is dedicated just for this one. Okay, HDFS, distributed storage, to process the information. You have stored the information, now you have to process the information. For that we'll be using MapReduce distributed processing. Also, when which process should execute, that scheduling is done by YARN. So repeat with me, what are the four things? Common utilities and libraries, HDFS distributed storage, MapReduce distributed processing, YARN distributed scheduling. Okay, now we will discuss each of these in depth. The first one is Hadoop libraries and utilities. What it provides is this is what you have to write after writing this one. It provides various components and interfaces for distributed file system and general input output. For handling the general input output as well as distributed file systems, it will be giving us the components and interfaces. Okay, so that we can perform the operations successfully. Okay, next is Hadoop distributed file system. HDFS, what is the full form? Hadoop distributed file system. It is a Java based distributed file system which can store all kinds of data. Okay, it can store all kinds of data on the disk at the clusters. Third is the MapReduce distributed processing. It is a system that processes large data sets parallelly, the two in batches. The last one is YARN distributed scheduling. In this, what we have, it's a software for managing resources for computing. This is all what you have to remember. It does what? What does YARN do? If someone asks you, what you will tell, it manages resources for computing. Okay, then this is just the further information how it manages, that you can go through it. Okay, so basically I told you what are the means use cases of each of these. It provides some utilities so that we can perform the program efficiently. It stores all kinds of data. It uses the parallel processing to perform the data successfully and this has some managing resources. Okay, that's all the key points you have to write and you have to explain in your own words. Okay, so that was about the core components with a neat diagram. Moving on, we have the next super important question, which is the features of Hadoop. Super important question, features of Hadoop, 8 to 10 mark question. So Hadoop has the following features. The first one is fault efficient, scalable, flexible, modular design. See, whenever we get these type of question like explain features of Hadoop, what are the characteristics, advantage, disadvantage, all at that time you have to create a story around it. Okay, so as of now I have not created any story around it. Let's see if we can create any story around it. See here, how many points are there? That's the first thing you have to see. 1 2 3 4 5 6 7. 7 points are there, right? So pick up one word from each of these. Fault efficient, scalable, flexible, modular design. What you can make out of this? It is a good. Okay, just keep in mind good includes it is having less faults, it's scalable, it is flexible, it is modular, means it can be divided into different small parts and executed parallelly. It is a good operating means good thing. So good is a point. You can imagine something which is like good. You can imagine any toy. Okay, there's a toy which is very good. Okay, so there is a toy doll which is very good. Okay, let's imagine like that. There is a toy doll which is good. Since it's about the Hadoop, let's imagine the elephant itself. There is an elephant toy. Okay, Hadoop actually means elephant only in some language. So Hadoop is the toy is very good. Okay, so let's see, that's the first point. And second one is robust design of HDFS. You know the toy which is there, right? It is of very high quality and it is made out of the rich cotton fiber and it is very soft. Okay, so that you can remember, robust design means the design is very good and it's very attractive to look at. And the toy is not small, it is very big toy. Okay, it's not fitting in your hand, it's like your own size only, that much big toy it is. Okay, it stores and processes big data. Inside that toy there is some secret, okay, that is getting processed. Okay, and by that you can remember the third point. And it's now you have one toy which is very good, which is very big, as well as its design is very attractive. Now, distributed clusters computing model with data locality. Now what happens is you only not have any toy. All those people who are listening this video at this point of time in YouTube, all those people have that toy in their home. Okay, and all what they do is they come to VTU and they train their toy. Okay, just assume like all those people who are watching this video, they'll come and train their toy in VTU. Now what you can remember is distributed clusters of computing. There are many different toys present at different locations. The data is distributed, that means, and it is data locality is there, means the distributed clusters are connected with the same data in middle. Okay, so what happens is all those will be meeting and each other and they will be trained by VTU. Okay, Now what you have to remember is hardware fault tolerant. After they have been trained, obviously they will be hardware fault tolerant. Right now they are more stronger, right? So they will be hardware fault tolerant. And open source framework. Open source basically means what? Open source means if any person is doing some project and the code is visible, if you see any errors in their code, what you will do, you'll correct that code and request them to correct it, and they'll correct it. Like that the code gets more better. That's what happens here when the elephants come for training in VTU. At that time, what will happen? Open source frameworks will be taking place, right? At that time, the VTU will be telling what is the mistakes you have. It will be correcting them, okay? And they'll be trained so that hardware fault tolerant they'll become, okay? And last is Java and Linux based. After I have come from training, what they will do? All the elephants will go to their home and kick you from the computer, and they will start learning Java and what Linux, okay? So that elephants will become software developers. Okay, so that's a stupid story, but it is helpful for storing marks, so I don't care. Okay, so again, revising the points of the features of Hadoop. When you hear the word Hadoop, you have to remember this story, which is a very big elephant is there, which is very beautiful looking, and it is a very big one, and everyone has it in their home. And at one point of time, they all means all the persons who have the elephant in their home, they bring in VTU for training. When the VTU trains it, it will become hardware fault tolerant as well as open source framework, means they will be correcting each other's mistakes. And when they get trained and they become very good, they become very much motivated, they'll come and kick their owner itself, and they'll start learning what Java and Linux. Now just quickly going through it, you'll be easily get to know what is the actual meaning. See, it is a simple and modular programming model along with scalable highly storage system. All these features are available in Hadoop. It is a robust design because it can continue to work even when the individual cluster fails. Storing and processing big data is self-explanatory, and distributed clusters are there. Processes high data efficiently, and parallel processing will happen because each one will be doing it separately at the same point of time. And hardware fault tolerant. Fault does not affect the data and application processing. If hardware fails, it does not affect the processing of the data. It is open source, access is available for all the people, and it's large database, and it uses the Java interfaces, and the UI is regarding the Linux, means the base of Hadoop is the Linux, okay, but it has own shell of command support, okay. So what is the features of the Hadoop? Nothing, just remember that toy elephant, okay. So let's move on to the next one, which is what are the four layers in the Hadoop ecosystem? A super important question from exam point of view. What are the four layers in the Hadoop system ecosystem components? The first key point what you have to write is, right, there are four layers are distributed storage, resource manager, processing framework, APIs. Okay, again you have to create a story around this. Okay, so what story you will be creating around this is, four layer mean what? There's a big elephant, right? In that elephant, if they ask you about the layers, if they ask you about the features, you have to remember that story which I told you previously. If they ask you about the layers means, if suppose that this is the elephant, okay, in the elephant there are four layers: top part, middle part, lower middle part, and bottom part. Four parts are there. So what do these four parts contain? That's the main question. Now as you can see, at the top of the elephant the people sit, right? People sit means what? The top part of the elephant is divided into many places, and in each place one person can sit, right? So that is what is called distributed storage layer. In the top layer there is a distributed storage where people can sit, okay. The next one is the upper middle part. In upper middle part, what is there? The elephant's head is there, right? In head, what will be there? The data will be stored, okay. Resource manager, all the data will be stored and it will be managed. In the lower part of the middle, there also the head will only be there. Their processing framework will happen. All the processing of the data which is stored, that will happen. So here people are sitting, here the data is stored, here the processing is happened, and at the last, API at the application support layers. APIs are used at the bottom layer. This you can remember. Why? Because API means what? Application programming interface. This is elephant and this is ground, right? Between elephant and the ground there is a connection via the lower layer. So lower layer is nothing but application programming interface. This is one app, this is one app. The elephant is one app, the ground is one app. The bottom layer is the API layer which connects the elephant to the ground. Means elephant is able to walk on the ground because of the bottom layer. If the bottom layer is not there, elephant will not live only. Without any legs, he will die, okay. So these are the four layers in what Hadoop. Distributed storage at the top, and below two will be the resource manager and the processing framework. At the end, it will be the API application support layers. Okay, so this is a very brief what I have drawn. If you see in the notes, there are many other things written along with that. But what I prefer is first draw this one. Okay, draw this one, and then after that explain each of these separately here. That will be so, looking so nice also, and you can easily add more points and fill the content also, instead of writing all this here like a stupid person. That doesn't look good also, and it is very complicated. So what you have to write is application layer is the first, then you have application support layer, MapReduce, YARN, and HDFS. See, whenever you access any app, okay, if you open any app in your social media, at that time what will happen, the app will get opened, and some API will be connected in that app, so that it will redirect you to what content you are seeing, right? That content is getting viewed from a different server, right? That content you are able to see. How you are able to see? You have opened the app. That app is what? Application layer. Then inside that app there is a application support layer which connects it to the actual server. After that, what will happen, the means data will be retrieved from the server, and there you will be able to see your information there, right? Whatever you are able to see, it is in raw format, but you will be able to see in the actual format. Like for example, in bits and bytes the data is sent here, but that will be converted to images or videos, and that will be seeing here, right? That is done by MapReduce and by using scheduling a tool which is YARN. These two, what it will do, it will convert the bits and bytes to the video format. After that, whatever the data you have seen, that will be stored in your browser history. That is HDFS. Okay, in that way you have to remember. The previous things they were given, it's not in the order. So but this is what the order actually is. Okay, the first part will be application layer. There the distributed data storage will be there. This is API layer. Here the coordination among components will be the different components. MapReduce and YARN, this is for the serialization and parallel processing, and here finally the data will be stored whatever is processed. So application layer, it consists what, this is the thing you need to write. It consists of frameworks and tool for data visualization and descriptive statistics and so on. For all of these things you'll be using application layer. Application support layer has the data flow, means how the data is connected from one part to the another part, and you have to write it executes frameworks queries for data aggregation and summarizing. It uses these things to make the data more simpler and efficient. Okay, MapReduce is used for parallel processing, and these are the tools used for it. And finally we have YARN. It's used for the managing resources for computing of subsets in parallel. It is managing the resources. That's the key point here. HDFS, as you know, it's the file distributed system storage. Okay, each data is stored using the block size of 64 MB. Okay, so this is what you need to write if they ask you what are the four layers of Hadoop system. Moving on, we have the next super important question, which is Hadoop storage architecture and commands. See, I told you, right? There will be many different questions with the same similar hearing words, but it will be very different answers. So you need to pay very much attention to what question, what answer is there. Hadoop distributed file system. Okay, this is the topic 3, Hadoop distributed file system. Explain HDFS storage architecture and its commands. Here three things are there. Explain HDFS. What is HDFS? First I have to explain that. Then explain what is its storage architecture. Then explain what are its commands. So in the same way only you will be answering. The first question will be answering what is HDFS. This is what you have to write. It is a core component of Hadoop. HDFS is a core component of Hadoop because how many core components are there? 4 are there, right? The second one is here, what I had written is HDFS, right? If you remember in the previous question, I had already explained this is the core component. This is one of the core component of Hadoop, which is HDFS, Hadoop distributed file system, right? So what it does is it is designed to run on a cluster of computers and servers at a cloud-based utility service. Means it will be running for a cluster of computers at cloud-based service. Okay, and it uses the big data. It stores the big data which ranges from GBs to PBs. Okay, and it stores the data in distributed manner because obviously the clusters are there. The data will be stored distributively only, right? Next question I will be answering, what is the HDFS storage. In HDFS storage, the concept implies storing the data at a number of clusters. Here's also the same thing. The storage, whenever you hear about the Hadoop, you have to see remember that it is getting stored in different locations. Okay, and each cluster has a number of data stores called racks. I'll be explaining this using the diagram directly. See here, this is the Hadoop cluster. What it consists of is different racks. This is called rack 1, rack 2, and rack n. Inside rack there are data nodes, one data node, two data node, 3 data node, 4 data node, and so on. And each data node has what different blocks here. Each one is called a block, and this is how much 64 MB. Okay, this is what the data structure, data architecture is. Okay, just for the storage. The other architecture is still remaining. We'll come to that at later point of time. Here the same thing is written. Each rack consists of data nodes, and each data node consists of large amount of data blocks. Each data block is of the size 64 MB. Okay, now let's see what are the features, Hadoop features. Okay, Hadoop features with respect to the data storage, not about the general features. Hadoop general features is what, that elephant story. Okay, but Hadoop features regarding the storage, those what we can do is create, append, delete, and rename attribute modification functions. Content of individual file cannot be modified but only appended. Write once but read many times. Average file size can be more than 500 MB. These are the few features of Hadoop storage. Okay. After that, you need to write about the Hadoop physical organization. Why we are writing that is because in a question they have asked the commands. To explain the commands, you need to write some architecture as well. So in the architecture, it's also very simple. A client is what, who sends the problem statement, right? Client what does what, sends the problem statement to the HR of the company, or the, I don't know to whom he sends, maybe manager of the company. But anyways, let's see, let's assume name node of the company. Okay, there is a person called name node. The person's name is name node. Client node comes and sends a problem to the name node, and name node what it will do, it will ask its boss or the CEO. There are two, the president, vice president, CEO, vice CEO, both are there. For both of them, he will be asking like this the problem statement. If he gets the approval, he will give the slave node the task to do, and that will be completed. The same thing goes in Hadoop also. Whenever there is an input coming, it will go to the name node. It manages which resources are used for which task, and the approval is fetched from the primary and secondary master, and then the task will be distributed among the slave nodes which work. Okay, so each of these has the functions as well as some tools used in it. So let's discuss what is that. Name node provides the name node management services. It provides what, management services. Slave node does the actual thing, which is the MapReduce operation. Client node sends the request using the command line tools. Master node fundamentally plays the role of coordinator, means it coordinates between the name node and the slave node. Okay, it also allocates the file blocks. Now, since we have understood this one, we are able to understand the HDFS commands as well. Few of the commands are mkdir. We can use to create a dictionary directory with the given username. For example, $Hadoop HDFS -mkdir /user /stu files dir. It creates a directory with what name? Stu files dir. In the same way, we can also copy the information from one file to another. For that, we have to use put. HDFS put, then whatever we have to put, where we have to put. Okay, so it copies it into a particular directory. LS is used for files to be listed. HDFS, DFS, LS. Commanders provide the listing of all the files. CP is used for copy pasting from one directory to another. The previous one, which is put, it is for just one file. So this is the code for it. Hadoop HDFS CP. Then the path is given from where it is to be copied to. For student ID 96 into student files directory. So this is what you need to write for the first question regarding the HDFS distributed file system. Actually, only one question is there in this one, but super important question from exam point of view. Moving on, we have the next topic, which is MapReduce framework programming model. The heart of this module is MapReduce. So you need to know this very well. Okay, so there are two questions here. The first super important question is explain the following: mapper, reducer, aggregator, query, and MapReduce. What are the differences between them? Mapper, what it will do? It will map the data, right? It is a software that maps the keys to the imported specific data that the application uses. This is what you have to write. What is the reducer? Reducer, it is used for software for reducing the map data using aggregation, query, or user specific functions. It will reduce the data which is mapped, okay, by using some functions. It will make it more simpler. Aggregation means grouping the values of multiple rows. This is what you have to write. It is a function that groups the values of multiple rows together to result a single value of more significant meaning or measurement. Querying functions, it is a function that finds the desired value. This is what you have to write. It is a function that does what? Finds the desired value. Suppose that there is a database here, you have to find some desired value. You will be searching that value here and you will be getting it. MapReduce, it is a tool which merges map and reducer into one application. It processes a huge amount of data parallelly. MapReduce makes it easier to process the data parallelly as well as huge data. That's all what you have to write in the first question of MapReduce. This is the basic terms. Next, let's understand what actually the features of MapReduce are. So there's no need to memorize it using a story. You can just memorize it like that only. Like what are the features of MapReduce? You can tell by your own words itself. By using MapReduce, you can do parallel processing on the distributed clusters, and large data can be processed. It is scalable, and large numbers of servers are also used, and additional modes and tools are present for efficient processing. Very simple, isn't it? You can easily remember this and expand each one in your own words. Like for example, if I want to expand this one, provides automatic parallelization. First, write what is automatic. What is process parallelization? Automatic means what? It will be having some code. By using that code, it will be processing the data. Parallelization means in the same way this code will be applicable for different clusters, and in each cluster the processing will happen and the data will be generated. When the data is generated, it will be merged and the processing will be done at the some layer, and after that the results will be obtained and that will be stored in the storage system. This will obviously take at least half or more page. That is sufficient for you. Like that, do for all of this. Fine. That's what I've tried in the second important question. Explain the features of MapReduce. Moving on to the fifth topic, we have Hadoop YARN. Here also one question is only there, super important. What is Hadoop YARN? Explain the model architecture and execution. What is Hadoop YARN? YARN is what? Resource management. This is the first point you have tried. Resource management platform that manages schedules for running subtasks allotted to the interval times. There are some interval times given. In these times, you have to perform some tasks. Which task is to be performed in which interval, that is decided by YARN. Further, some codes are there inside that. The full form also, it's helpful for you to remember. Yet another resource negotiator. It manages and allocates the resources for the application subtasks. Okay, that was about what is the Hadoop YARN. Next is explain the model architecture. Let's see what is a model architecture and its execution. In execution, here also the same thing. Client requests something to resource manager. It gives to the node manager. It does something and returns back. So let's see what is actually present here. You have to make it in the same way. Clients are there. It makes the request to the resource manager. It will decide whether the task is performable or not, and it will give the task to the node managers. In node manager, there are how many things? Two things are there. In node manager, there are two things: containers and AMIs. So let's discuss what are containers and AMIs. These does these tasks sent to the node manager. It will return back to the resource manager. It will send back the result to the client. A client node submits a request. What does a client node do? It will obviously submit a request to the application of the RM. Resource manager is the master. What it will do? It will keep all information of the slave NMs. Multiple nodes are the clusters. What does the NM do? It will use AM instance to start up. AM means what? Application manager. It performs the role of application manager in its startups, performs the signal, means perform the operations, and it will be sending back the output. Okay, that is what Hadoop execution model is and how it works. Moving on to the sixth topic, which is the last topic in this part of the video, Hadoop ecosystem tools. What are the Hadoop ecosystem tools? Just one words are sufficient. You can easily remember: Zookeeper, coordination service; Arvo, AVRO, okay, Avro, data serialization; Uzi, packages; Scoop, RDBMS handler; Flume, data reliable data transfer. For transferring the data, we'll be using Flume. Just briefly go through it. Even if you don't remember, it's fine, no problem. And Ambari, which is monitors and manages the tools, and Chakwa, which is data collection; HBase, it's scalable structured database; Cassandra, which is database for clusters; Hive is the database data warehouse and its application tools; Pig is the data flow execution; and Mahout is machine learning and library functions. So again, going through it, Zookeeper is used for what? Coordination service. Remember like this: in zoo, if you go Zookeeper, what he will do? He will coordinate with you and give you the tickets and all, right? That is what. Avro, like avocado, you remember avocado, you'll be remembering data serialization. I don't know how connection you'll make. Uzis, just think Uzis has some storages. They will be storing some data like Orbi balls, right? In that you'll be storing some data. Okay, and Scoop, remember the ice cream scoop. When you take in that, what scoop you are taking? RDBMS flavor scoop. Okay, Flume you can think of as flame. When flame is there, the data will be transferred very fast, like fire emoji. And Ambari monitors and manages tools, so you can remember it like this only. And Chakwa, data collection. Chakwa means it can collect the data like a chewing gum, And HBase, it's the scalable and structured database. It's Hadoop based, so it is obviously scalable and structured also. Cassandra, it's used for clusters. Cassandra and clusters, these two words you can remember by itself. Hive is nothing but honeybees hive, so honeybees live in what data warehouses. And pig is what data flow. Pig will be always in the gutter, right? So they will be flowing in the gutter only, so it is a data flow and execution is happening there. Okay. And Mahot, M for Mahot, M for machine learning. Okay. So if you like this video, hit the like button and don't forget to subscribe to my channel. Your support helps me make more videos like this. And thank you so much for watching. I'll see you in the part 2.